Another problem type wants us to identify whether an equation is a function or not, or really a relation, whether a relation is a function or not. And so we need to know a few things about functions. First, functions describe a cause and effect. An input creates an output, and it's reliable. With the same input, we will always get the same output. If I work 10 hours and I'm paid $10 per hour, I should have $100 of gross pay. Next week, if I work 10 hours, I should get $100 of gross pay. A year from now, if I'm still making $10 an hour and I work 10 hours, I should get $100 of gross pay. That should never change. We could represent that with a function. If, on the other hand, this week I got paid $100, and next week for the same amount of work and the same pay rate, I got $30, and the week after that I got $80, and the week after that I got $200, and the week after that I got $75. We're getting different outcomes for the same input. Well, that's not representable by a function. So functions have a one-to-one relationship. One input creates one output. Well, let's take a look at it. So each x has only one y value. So these are x and those are y. Our x is our input and our y is our output. If you notice, this x has one output. This other x has one output. That x has that output. This x has this output. We don't have the same x values. So we could say that this has a one-to-one relationship because for all of these x's, for each x, there's one y that is related to it. So we have a one-to-one relation. This makes this a function. So I'm going to put a check next to it. That checks out. Well, let's take a look at this other function. This is still a one-to-one relationship. And it looks kind of crazy because this x maps to that y. And a different x maps to the same y. And yet a different x maps to the same y. Well, that's still a one-to-one relationship because that input only has that output. That input only has that output. It's a one-to-one relationship. And you could consider this like if you spent $8 to go in and you got up to 12 tickets to ride rides. If you rode 3 rides, it's still going to cost you $8 to get in. If you rode 9 rides, it's still going to cost you $8 to get in. If you rode 12 rides, it's still going to cost you $8. But now we have a different outcome. If you want to ride more than 12, you have to pay extra. So it would cost a different output. And the output would be the cost of going to the carnival and riding the rides. So it's okay that we have this input and that output, and this different input, we have the same output. And again, because we only have one output for that input. Well, let's look at something that's not a function. You see this 4? This 4 as an input one time we get the output of 2, and then the next time we get the output of 4. So that's a one to many. That's not a function. We cannot derive a function from that relation right there. Now, can we get a correct relation? Sure, but we can't get a function. All right, well, what if all you have are numbers in a table? Well, if in a table, look for repeating x's. If you have repeating x's, then you take a look at the y's. If it's the same y, each time, that's okay. You still have a function. So if I have 100 employees and some employees are paid $12 an hour and some are paid $15, and they, some work 20 hours, some work 30 hours, some work 40 hours. Well, I would take the number of hours they work times how much they get paid per hour, and that would tell me how big their check would be. Well, if they work the same number of hours, and I got 7 employees that work 20 hours and they make $12 an hour, they're all going to have the same size gross pay. So it's okay that we have 7 of the same X, because we're getting the identical Y for each time there is that X. So if you have a one-to-one relation, it's a function. If you have a one-to-many relation, it is not a function.